Okay, let's talk through these problems. Solve each equation and check your answer. These are problems where there's the variable on both sides. So let's see what we do here, okay? First thing I want to do, I'm going to explain why I'm choosing to do exactly what I'm doing. You could move any number of things. What I'm doing is I'm choosing to, as you can see here, there is 4p plus 2, and then at the end of it, I'm putting minus 3p. Why did I choose to subtract 3p? I did it on this side as well. Well, this is where a little bit of understanding of what you're doing can make things easier on you. Okay, because what's going on here is I know that there is 3p over here, and I need to get all of the p's isolated. So if I take away 3p and there was 4p here, I've got 4p minus 3p, and look what it results in. It results in just p. They go away over here. Okay, 3p minus 3p, leaving just that negative 7. Okay, but 4p minus 3p combines to be just p, and that's something that I really want to have is just a single one of the variable. Okay, now there's still the plus 2, and I'm trying to completely isolate the variable. So what happens then? Well, I take that p plus 2 and I take the 2 away from it. I have everything that was already there, take away 2. Everything that was already there, take away 2. And when I say this, I'm really urging you to do it like this. If you're going to subtract like I'm doing on the same line, first write everything that's already there, p plus 2. Start with what's already there. At the end, that's what you add on. If you do it this way, then you know exactly what you're doing because we can just look and say, oh, the last thing that was there was the minus 2, and that wasn't there before. Okay, if you bury it somewhere else in the problem, then it makes it harder to see what it is that you're doing. Okay, so now when I combine the terms, I get over here, the plus 2 and the minus 2 go away to be just p, and the negative 7 minus 2. Okay, now let's take a look at what the proof looks like. Okay, we've got our original problem. I am going to rewrite the original problem with parentheses wherever the variable was, and I'm going to substitute that negative 9 in for p. What we had found down here at the bottom for the solution, p equals negative 9, then p and negative 9 then are interchangeable. Since they're equal to each other, you can just put negative 9 wherever you saw p, and you're writing an equivalent statement. Okay, if you are not putting parentheses, you are doing it wrong. I'm just telling you this. You'll keep getting your paper kicked back to you if you don't learn that, so learn it now. Okay, now what do? Well, now I need to simplify. What do I simplify first? I got to do this multiplication before I can do this addition. Likewise over here, I need to do this multiplication before I can do that subtraction. Okay, so 4 times negative 9 is negative 36. And then we've got the plus 2. 3 times negative 9 is negative 27, and then I've got the minus 7. The last thing that's left to do is combine these, and I get negative 34. Negative 34 equals negative 34. And I give it a check because that works out. That's proper proof.